Hey everybody, this is Jason, the ASD manager over here at the Children's Museum of Houston. And today I want to talk to you guys a little bit about chemistry. Give you some activities so you can understand how chemistry can work with really simple materials in your everyday life. First of all, what is chemistry? In the simplest terms, chemistry is the science of change. And what we mean by that, it's how matter changes. And we all know that matter is anything that takes up space. We also probably know that matter is in 3 states. Well, actually, it's in 4 states. The most commonly taught states of matter are solids, liquids, and gases. The 4th state, known as plasma, is actually the most common state of matter there is. Every star in the universe is made of plasma. Lightning strikes are plasma. Anything that has an electrical current running through gas becomes plasma. So plasma is very, very abundant in our universe. The other states of matter, solids, liquids, and gases, we can really only look at them here on the Earth. We know there's a lot of liquid here on the Earth. Water, this stuff right here. One of the most abundant liquids we have. Solids, like this table. And then gases, like all the air around us, are all here on the Earth. And all these solids, these liquids and these gases, they go through change. What kind of changes do they go through? Well, let's think about water for a minute. Let's think about this. Without water, we don't have life, so it is very important to us. But we also know that water can change. Right now, you can see that it's in the liquid state. It takes the shape of this bottle, this jug here. It has a definite volume, but not so much a definite shape. It can change the shape a little bit. Solids, on the other hand, like on the table here, they have a definite shape and a definite volume. And then you have a gas, which doesn't have a definite shape nor a definite volume. It can fill anything up the way it seems fit to do so. Gases are also highly compressible. That's important to remember. Now let's talk about this liquid water for a moment. What if we were to lower the temperature of this liquid water to 32 degrees Fahrenheit or 0 degrees Celsius? What would happen to it? It would turn into a piece of solid ice. That right there is chemistry. That's a physical change. What if we heated this water up to 212 degrees Fahrenheit or 100 degrees Celsius? It would turn into a gas. You would see steam coming out. That's a physical change as well, and that is chemistry. So when you think about chemistry, all you really need to think about is how things either physically change, they change how they look, but they don't change at the molecular level, or you think about chemical changes. They change at the molecular level and become something new. And that's all it is. So when we talk about states of matter, there's a couple of really fun experiments we can do to give you an idea how things can go from a liquid to a solid into a liquid, things like that. So let's do those right now. First thing I'm going to do is I'm going to make you some slime. All right? This right here is a glue solution. It's half water, half clear glue, with some food coloring in it to give it a little bit of flair, if you will. In this bottle, I have borax solution. I filled this half-gallon jug full of water, put 6 tablespoons of borax in, and I shook it up. Borax is a solid, but there's very little borax in here. The rest is liquids. What I'm going to do right now is I'm going to take these 2 liquids, I'm going to put them into a ratio. I'm going to place them into this bag, and I'm going to make a solid. Let's see how we're going to do that. First of all, this cup right here is 1 ounce. It's a 1 ounce cup. So I'm going to put 1 ounce of glue solution into this cup. You got to be careful. You don't want things to break or spill. So 1 ounce. There it is. You all see that? Awesome. Next, I'm going to put a ½ ounce of the borax solution into a different 1 ounce cup. So I'm going to fill it up about halfway. Again, you want to be really careful. There we go. It's okay if you spill a little bit, it won't hurt you. What I'm going to do next is this. I'm going to go ahead and first put the glue solution into this bag. Then I'm going to put the borax solution on top. I'm going to seal the bag up, and I'm going to start to knead it together. Even from the very beginning, can you see how much more solid it's becoming? What I'm creating right now is a polymer. A polymer is a long chain molecule with repeating subunits. What's happening here is I'm bonding together the borax solution and the glue solution. And all the water in both solutions are being trapped between these repeating subunits. And the more I squeeze it together, the more solid it becomes. So this is also an example of what we call a non-Newtonian fluid. Most fluids, or Newtonian fluids, are affected by their temperature, their viscosity. Viscosity is something's resistance to flow. If you're viscous, you don't flow very well, like honey. When you have a non-Newtonian fluid, when you squeeze it together, you're making it more and more viscous, more and more resistant to flow. Or, in the case of ketchup, if you shake the bottle, you make it less resistant to flow. So non-Newtonian fluids are affected by both temperature and by pressure. Newtonian fluids aren't affected by pressure, just by temperature. Take water, for example. It has a certain viscosity, okay? You heat it up, it becomes a gas, which is also a fluid, the viscosity changes. You cool it down, it becomes a solid, the viscosity changes. But it's all due to temperature. Here, I'm changing the viscosity simply by applying pressure, okay? I'm giving it stress. Now what I'm going to do is I'm going to take it out right now, and you're going to see how I took those two liquids and basically made a solid mass. This right here is what we call clear glue slime. And if I knead it with my hands, it gets even more solid, and it can do stuff like bounce around and things, okay? So I've made this into a very strong polymer that has become quite viscous. It doesn't seem to flow at all. It's very solid, okay? So that's one example of how I've taken two liquids and chemically changed them into a solid. And this stuff is really fun to play with, so you're going to see me play with it for a while. Okay? And it's really easy stuff to do. Like I said, clear glue and water, half and half, borax solution, which you can find at the store, 6 tablespoons, and a jug of water, and you're good to go. And you can take this and play with it and show your friends, and it's a good old time. I want to show you another non-Newtonian fluid that's made from a solid and a liquid. This one we're going to call Oobleck. Sorry, I got my hands all dirty, but it's okay. What I'm going to do right now is I'm going to take this bowl. This is cornstarch right here, all right? I'm going to open up this cornstarch, and I'm going to put 2 cups of cornstarch into the bowl. So here's 1 cup. And here's 2 cups. All right. Now, I'm going to put half as much water in. So if I'm doing half as much water, it'd be 1 cup of water. The ratio to make this stuff called Oobleck is 2 to 1 in favor of cornstarch. So if I put 4 cups of cornstarch in, you put 2 cups of water. Fortunately, I have water right here. So I'm going to put my cup of water in. And this is when it becomes really fun. I'm going to pour the water in. I got some food coloring here. I'm going to put the food coloring in. Just a few drops. And then I'm going to mix it together with my hand. Your hand will get kind of red or green or blue, depending on what kind of food coloring you use. Now as you do this, you might notice that it's like a little sticky, getting a little solid maybe not too solid, maybe not solid enough. So you can decide if you want to add a little bit more cornstarch into it, a little more water, depending. okay? Once you do this a couple of times, you'll kind of get the ratios that you need. You'll kind of figure out what you need to do. Mine right here, right now, is a little too runny, so I'm going to add a little bit more cornstarch. So I'm just going to use my hand and add a little more cornstarch in here. Okay, I'm going to turn it over again so you can see. And this is getting to the consistency I want it to get, okay? Now, what's going to happen here is this Oobleck stuff is going to act like quicksand. You guys have heard of quicksand before, right? Sand that you fall into and you start to sink. Well, this is very much like that. What happens is if you fall into quicksand and you start to struggle, you actually cause it to become more solid-like and become more viscous, and it starts to grab you and pull you down. If you just let it go and just kind of stand there, it'll be more like water, like a liquid, and you won't sink in. So what happens here is when I grab a big chunk of this, it's like a solid. But when I let it go, it becomes very much like a liquid. So this is a non-Newtonian fluid as well, but quite different from the slime that we used before. As you can see, with no pressure, this one starts to become very liquid-like. And you can start to see this one's flowing a little bit. It's starting to fall a little bit because of gravity, but not quite the same as the Oobleck. So these are two different experiments that can show you a lot about the difference between solids, liquids, and gases, can tell you something about non-Newtonian fluids versus Newtonian fluids, and even tell you a little bit about what viscosity is. And it's so much fun to always do that. All right, guys, more chemistry coming up. Thanks for sharing your time with me. We'll see you in a little bit. Thanks.